All right, so today we're going to go over Chapter 4, which starts in your book on page 212. It's called Debugging and Error Handling, and then we're going to look at some stuff regarding that afterward. I'm hoping that we can get all that done and still give you at least a couple hours to work on your work. So you can see here that here are our objectives. We want to be able to recognize error types, trace errors with dialog boxes in the console, use comments to locate bugs, trace errors with debugging tools, and write code to respond to exceptions and errors. There is a lot in this chapter. It's an introduction to debugging. All right, I've emailed you some resources this morning, and I'm going to go over some of those after we get done with the chapter. Now, I'm going to show you something, and probably a lot of it will make sense. But if I come through here and I start to create myself, let's just say I'm creating a JavaScript program here. I'm going to put a main in there. And this is one of the places where, just so you know this is one of the places where JavaScript is different than other languages. Okay? So I'm going to purposely make some mistakes in here. I'm going to say var age equals 21. All right, and then I'm going to say here document.write, which is supposed to write it right to the page. And I'm going to purposely make a mistake in here. Now you can all see this, you're all smart people, that I put the A and age in capital letters. All right. So if I come through here and I say something like this, let's say that I wanted to actually put age equals there. Now, my guess is what's going to print out there is age is undefined. I think that's what's going to print. All right, I'm not going to try it right now, but we could. The point is, if you try this in virtually any other language, the program will blow up right there, especially languages that are strongly typed. Okay? You've also seen that I can come through here, so let's make it correct. All right, now it should print out age equal 21, just like you think it would do. All right, so that first one would have been age is undefined, or equals undefined, I guess. And the second one should print out age equal 21, which is what we'd want to have happen. Again, one of the places where JavaScript is so forgiving is if I do this, it'll still work. How do I know that? Because I look when you turn your stuff in, and a lot of you leave one or more semicolons off at the end of lines, and it still works. This again has to do with the makeup of JavaScript, the way that it's set up. All right? I will tell you that let's suppose that we did this, because you may or may not know what I'm about to show you here. You've seen me make things like this before, where I come through here, and now I'm going to put in another function that's called add2, and we'll just call it n1 and n2. And I'm going to say return n1 plus n2. Now you may or may not have noticed, I purposely left the semicolon off. This is one time where JavaScript may complain that you don't have a semicolon at the end of the line. All right, so always make sure, you really should always make sure that you have semicolons at the end of any executable line of code. Remember, you don't put one after an if, or after a case, or after a while, or after a for. You do put one after a do while. All right, not after an else, again, etc., all those other ones. All right. Now, again, what's weird about JavaScript, what we talked about before, is if I come back in here and I say return n1 plus, let's say I make another mistake here, n3, and I do put that in. Literally what JavaScript does is it creates a brand new variable named n3, but it doesn't have any value to it. When you try to add 1 plus undefined, or 10 plus undefined in this case, it's probably going to give you an error message or something about undefined. It probably will say just undefined for the answer. But again, this is where the language itself is so forgiving that it's not a good thing. All right? Now, if I do come in here and I do this, again, I purposely have done that. I spelled function incorrectly. All right? That will be a syntax error. So a syntax error, which is one of the 3 types of errors that you can get in any programming language, a syntax error is a violation of the rules of the language. That's what it is. All right. Again, for example, next semester, if you write the same kind of program in C# and you leave those semicolons off, you're going to get error messages. The program will not compile. If you spell, function or whatever it is wrong, you're going to get error messages. All right. It's not nearly as forgiving. If you do that thing I showed you before with age or with the N3 here, error messages. All right. All right. Now, another thing that JavaScript allows you to do, again, that most other languages don't allow you to do, is if I come through here and I'm just going to add this, it doesn't make much sense, but I'm going to say var A equal 10, var B equals 0, var C equals A divided by B. Now, you know as well as I do, we've talked about this before, all right, that the answer to that should be infinity. And I don't remember what JavaScript does. I think it says INF to represent infinity right there. But in most other programming languages, when you run that, the program will blow up. That's what's referred to as a runtime error. All right, so a runtime error, which is the second type of these errors, is an error that's not uncovered until you run the program. All right. If I had come in here and instead of saying add to like this, I had just said add, that'd be another runtime error because the system is going to go out and it's going to look for a function named add and it won't find it. But there's nothing syntactically wrong with this. So it won't find those errors until you run the program. All right. The last type is, let's say we did add 2 here. All right, so we want to return n1 plus n2. Everything is all hunky-dory now. But accidentally, instead of saying plus, we say minus. All right, and that is a logic error. All right, they're the hardest to find because they're programmer induced. In other words, you made them. And they're the hardest to find because your errors, when I say you, when you are debugging your own code, those are the hardest errors to find. All right? People just don't, I didn't do that. Well, someone did. Doesn't matter who did it. Someone did. All right? Geez, I don't know how that happened. Yeah. You're the only one there. It's your machine. You're the only one typing, but you don't know how it happened. Okay. All right. So keep that in mind as we start because this is one of the questions, might even be 3 of the questions on the test. I don't remember. But you're expected to know. And those won't be the exact definitions that the author gives, but they're the ones that I use. All right. So they mention in here the more JavaScript programs you write and the more complex they are, typically the better the chance is that you're going to introduce bugs into your program. A bug is an error. All right? And there are many different ways that you can debug a program. Again, they talk about syntax, they talk about logic here, they talk about what bugs are here, etc. They mention don't confuse a bug with a virus or a worm. A bug is a problem in a program because of one of those 3 types of errors that we talked about. So again, here's how the author identifies, defines a syntax error. On page 213, a syntax error occurs when the interpreter fails to recognize code. All right? You have violated the rules, JavaScript's rules in this case. It doesn't understand what you're trying to do, so it gives you an error. Runtime errors, as it says, a runtime error occurs when the JavaScript interpreter encounters a problem while the program is executing. So syntactically it's okay, but while it's running, it encounters something it doesn't understand, so it flags it as an error. All right? And then finally, the logic errors. As it says, it's a flaw in the program's design that prevents the program from running as you anticipate. Again, they're the hardest ones for you to find, but typically if you're having a logic error and you can't find it, and you let someone else look at your code, they'll typically find it right away. Because a fresh set of eyes, will uncover something that you just have glossed over. And they give an example in here that's similar to the one that I showed you. They give another one. Technically, if you look at this right here, it should say count minus minus or something like that. You're going to get an infinite loop. An infinite loop is a logic error, unless you purposely planned on there being an infinite loop. If there's an infinite loop in the program and you did not plan it, all right, it is some kind of logic error. So throughout this chapter, okay, they mention here, it says, keep in mind debugging is not an exact science. In other words, no two people debug in the same way. All right, just so you're aware of that. And the way that you debug is the way that works for you. I'm going to show you about a half dozen different ways to debug during this chapter. All right, virtually all of them are introduced in the book, but some of them we'll look at in a little bit more depth and breadth of coverage. And I'm going to make some suggestions for things that you do as you go on. You're going to follow those or you're not. It's your call. But in the chapter here, you work on this. Tuba farm equipment. And the idea as you work through this, if you notice these are check boxes, so you can check one or more under which crops do you grow. If you check one, then you uncheck it, you're going to get an error right here. It's going to say you must check at least one of these. All right. They've also put some code in here, so it is not possible for you to put a negative sign in there or something non-numeric. You can only put numbers in there. You can put a god-awfully huge number in, but they must be numbers. And in here, I believe not only is it set up like that, but I think it's set up that it can only go between 1 and 12. All right, because it's the months of the year. And I don't remember what this one is. All right, but just so you know that. And it's not hard because this is just an HTML form, right? All right, so you can either set up what's called a regular expression pattern in there, or you can make that a number. And you can have the minimum set to whatever. These pretty much should make sense. This, again, you set to a number. You make the minimum 1, you make the maximum 12. All right, so that's how they set it up. So throughout the chapter, you work with this. Now, be it good, bad, or indifferent, not only do you work on this tuba farm thing throughout the chapter, at least 2 or 3 of the exercises at the end of the chapter also work with this. So it's going to be really important that you keep working with it and you start right here. All right? So they have you open it up and they show you some of the things and how it currently works, what it does do and what it doesn't do. All right? They mention here that if you do happen to be looking at this and you've got a really small screen or you're looking at it on a mobile screen, it's not responsive. Notice, that's the key thing. On the bottom of page 217 in the book, the author says, this file contains several code errors, which you identify and fix throughout the chapter. So if you notice an error right now, it will be fixed later, is what the author is trying to tell you. All right. On page 218, bottom of the page and going up to the top of the next page, interpreting error messages. Some of you have already been working with this. Again, we're going to take a look at going to the console in just a bit, and I'm going to purposely make some errors in there. So many of you have already been doing this, and you're developing a comfort level with it. With those of you who are not doing it, you will start. All right? If it's the test, the next hands-on, and you're working on this, and you say, you raise your hand, I walk over there, you go, I just can't fix this error. I'm going to say, bring it up in the console. All right? So remember what I told you earlier in the semester, and I've gone back and said it again also. Write a little code and test it. Write a little more code and test it. Don't write a lot of code and then start to test it. The chances are very good you're going to make more than one mistake, and then it'll be hard to find. All right? The author says here, 2 important pieces of information are displayed in the error messages. One is a description of the error message, and the other is the line number where, as far as the system is concerned, you made a mistake. So if you look in here, there's what it's telling you. All right. And typically you click on the top one here, there might be more than one, and it'll try to take you to the line in question. Now that line in question might not be the exact line where there's an error, but it's the exact line where the system thinks the error is. So it's never going to be after that, but it could be between line 1 and anywhere in there. Maybe I've told you about this. I say stuff like this. People think I make this up. I can't make up stuff like this. Remember this one student, he was having problems, and I could just see him. He was like this, and he could, and it was like I walked away. I said, is everything all right? He goes, well, I don't understand this. And I said, what's the problem? He said, I've been trying to debug this program for a half an hour. So what's the problem? Well, it says that the error is on this line. I said, yeah, because it's a blank line. So he just kept staring at the blank line. He wasn't going to fix it. All right, I said it's between line 1 and that line. And here was just a couple of lines up above that. All right. The author says stuff in here, and sometimes you might agree, sometimes you might not agree. There's 2 people who wrote this book. It's Sasha Vodnik and Don Gosselin. I've read Gosselin's books before. I've never read Godnick's. But sometimes they put in here their own feelings on things. And what I mean is, if you look at this is the bottom paragraph on page 220. The author says you can compare the way browsers render HTML and interpret JavaScript to the way human beings comprehend language. In other words, they're not all going to do it the same way. So if you hit F12, which we talked about before, which brings that up, it brings up the Chrome developer tools in this case, and you're in Firefox, instead of bringing up the Chrome development tools, it brings up Firebug. If you do it in IE, it brings up the Internet Explorer developer tools. So it might look a little different as far as what the error message is, etc., but they all should pretty much work the same. So you go through that exercise, you start fixing it here on page 221 and 222. All right. The author says on the top of 222, you may see additional statements in your console, including notes about CSS rules, etc. You may also see messages. All right. And the stuff that's in there is designed to help you as you're looking through here, so you're not confused over what any of the stuff that's in there. So jumping up to page 225, the top of the page, using basic debugging techniques. All right. So let's assume for a second here that I'm writing a program like this. Okay. So I've got this, what I showed you before. X is equal to 10, Y is equal to 10, Z, is going to be equal to the sum of those two, but I've got a logic error in here. All right. And I can't figure it out. For some reason, I just look at it and I cannot figure it out. So I can always come in here and I can say, alert, the sum is, and let's say I make the same error. And then I have to put it in parentheses here to tell it to do that first. And I'm going to say N1 minus N2. All right. Does it make sense to everyone that should come out and say the sum is negative 10? Does that make sense? Because I'm doing a subtraction. All right, so 10 minus 20 is going to give me negative 10. Now, what's really bad, because I've seen people do this, is they do this. So they type it in here correctly. So it does say the sum is 30. But then when they return it, They put it in there as a minus, and they literally look right through it and can't see that. That's a real logic error. All right? Don't think you won't do stuff like that. Everyone does. I've worked with professional programmers who know a heck of a lot more than I do. And I remember I was doing some database work with a guy years ago, and the function that he had to call, it was called DB, was called DB, and it was case sensitive, fast, read tub. And he was looking at it for a long time. He was one of my mentors. And I don't know why, but for some reason, he put an extra P there. He never saw it. And I went and told him, I said, Dave, there's an extra P there. And he's just like, look, oh my God. But he had looked at it for so long that he just didn't see that it was even there. All right? So I can put in alerts, and hopefully that will help. If I do this, and let's assume for a second that I do this, and I put in N3, and I don't have an alert in there. So I run the program, and nothing happens. Literally, nothing happens. And I, just for the life of me, I'm looking at it, I can't figure it out. All right? Well, then one thing I can do is I can comment this line out, say probably that line, so I can come in here and I can say, I can do another alert, and I can say something like calling function add to backslash n, and then I can, whoops, that's not a backslash n, and I can say x equals plus x plus y equals plus y. Now, what should happen out of there, and hopefully you all understand this, but what that should print literally on the screen here in an alert is calling function add to, then I should have a line break, and it should say x equals 10, and then it should have another line break, and y equals 20. Does that make sense to everyone? Because sometimes that's the best way to debug. Because I'm saying I'm about to call this, and if it tells me I'm calling it, and it says, and I know that I'm calling it, and I'm calling it correctly, because it's telling me the 10 is going to go here, and the 20 is going to go here, then I know the problem's not in here. Does that make sense? So the problem then has to be in here someplace. What you're trying to do when you're doing this is you're trying to narrow down where the error might be. So I'll take your question in a sec. One way, again, that you can do that is to use alerts, and another way is to comment code out. Yes?
But why is add to N1 and 2 not X and Y?
Oh, again, remember, these are called actual parameters right here, those. These are called formal parameters, whoops, here. They could be the same. We could do that. That's not a problem. But if I'm going to call this multiple times throughout the program, I'm going to have X, Y, I'm going to have A, B, I'm going to have JK, etc. Then I might want to just give them a generic name. Yeah, and sometimes, I mean, they're going to be a name like this. All right, so when you call it then, it's number 1, and it's number 2. And it's not so much that programmers are lazy, but it's like, why do all that when I don't have to, type of an idea. All right. No, that's fine. All right, so tracing errors with the alert is what I just showed you there. And that's what they're showing you on 225, 226, and on 227, they actually have a big example where they put a bunch of alerts in there. Remember what's kind of bad about an alert? Would you all agree that if I write a JavaScript program and I put this in, right here, what I just showed you, if I put in this, would you agree that an alert box comes up on the screen with the information that I think it's going to have, and then it'll have like an OK button? That's called a modal, M-O-D-A-L box, because I have to answer it. I can't go on with my program until I answer it. All right? And alerts are kind of a pain in the butt, because if I've got 5 or 10 of them, and I'm in a loop, and I keep, let's say I'm looping something 10 times, and and I've got 5 alerts in there, that's 50 times I'm going to get an alert. That's pretty bad. It's going to make it very hard for me to run the program. All right? And that's what the author is warning you against here on pages 227 and 228. It's not that it's a bad way to debug. It's not. It's a way of debugging. So you go through another exercise then on 228, 229, 230, all right, which gets us to page 231. On page 231, it's another exercise, but the author talks here about using console.log. This is another way that you can debug. So if I'm going to bring up the F12 again, and I'm going to go to the console, all right, which is where I am right now. If I wanted to, I can use this. I can type it. Notice what happens here. var x equal 10. Don't worry about the undefined. Okay? var y equal 20. var z, I'm not going to write a function. I'm just going to say equals x plus y. All right, now notice if I say x, 10, y, 20, z, 30. So you can work in the console if you want to. You can actually type code in there. All right? Or let's say that for some reason I just wanted to print hello world on the screen. I can type in console, and notice what it does. The IntelliSense kicks in, console.log hello, and I'll put world in there. And you see how it puts that in. All right? And I believe, I read something a long time ago, I believe what happens, the reason you get undefined here is it's storing that variable in a temporary storage area called a buffer. So when you do that, it doesn't have its value yet. All right, so don't worry that it says undefined. And there's a button up here. Notice if I click this, clear console. So I can type whatever I want to in here. I can actually put in my JavaScript, in here, I can put console.log statements in there. And then it'll send information to this. Does that make sense? So that's 3 different ways that you can debug. You can comment stuff in or comment it out. You can use alerts, and you can use console.log. Now in the book, they show you a much more extensive example of using console.log than I just did on 231 and 232. Sometimes when this happens, and believe me, if you haven't experienced this yet, it's just because you haven't been doing it long enough. I'll take your question after I finish this. But you're working on a program, and for the life of you can't figure out what the problem is. All right? I will tell you, because I looked at yours, I was very forgiving when I graded homework, by and large. All right? I won't mention names, but one person who's in this room lost a point on their last assignment. If you remember the thing that we did in class where you put in the 5 tools, remember that? One of the things you had to do at the end was you had to put in this. And one person in here didn't put that in. You lost a point. All right? Remember that when we were working on the example, remember I think you were writing a routine that was called process input. You wrote a function called that. Everybody remember that? At least one person in here did this. What's wrong with that? What?
It's not going to find
Yeah,
it.
why?
It's not the same.
Because it's not the same. You're right. Whoever said the I is not capitalized. You have to start being really meticulous because by and large, most every language is case sensitive. I mean, would you, this is like putting it to the extreme, but let's say you were going to write your own website. You were going to call it Java Buzz. All right? Would you really probably want to do it like this? JAVABUZZ, where you just did, probably not, unless you were trying to make a statement that way. So you have to get really used to looking at it. All right? So when your program does not work, go to the console. If you've written the whole thing already and you haven't tested it, well, shame on you, but go to the console anyway. If it doesn't show anything, start commenting outlines. then you can figure out, once you comment it back in when it doesn't work, that line has got to be an error. All right? Go ahead.
Does anything you type in the console get saved between opening?
No, that's a good question. The answer to the question is, or the question was, does the stuff you type into the console get saved? The answer is no. It's a temporary holding area. All right, so you'd have to copy it and throw it into a notepad file or whatever. You can actually write JavaScript. I mean, it would take a little work, but you could write yourself a program that would create a file, capture all that, throw it to a file, and then save it on your hard drive or something, but that wouldn't be a small endeavor. But you could do that. Now, on the bottom of 232, the author mentions here, and you already know what this is. It can be helpful to use a driver program. That's what I've tried to make main. It's a driver. Remember, it just calls the other routines. It's exactly what they're talking about here. All right. There's another exercise then on 233, 234, 235, and 236. Then on the bottom of 230, well, went too far. The bottom of 236, again, commenting out code, we already talked about that. But on the bottom of 237, and going on to the top of 238, the author mentions quite often you'll combine these. So you can do a log statement, but you might still be commenting out code, and you might still have an alert, etc. And that's what they have you start doing in the exercise on 238, 239, and 240. Now on the bottom of page 240, the author says, I'm sorry, it's 241. The bottom of 241, the author says, tracing errors with debugging tools. That's what I've been starting to show you. All right? Now, I'm gonna break away from this for a little bit. I wasn't gonna do it like this, but I am now anyway. And that is, what I'd like all of you to do is, if you could please, I'd like you, if you have, hopefully you have your machine on, but I'd like everybody in here to type in this URL that's right here. So open up a browser window and please type in that URL. If it comes up and it says Code School and it says Discover Dev Tools, that's where you should be. If you think you're typing it in correctly, and for some reason it's not showing, please raise your hand and let me know. All right? Code School typically charges for their classes. This is an entire class on how to use Chrome's developer tools. And the entire thing, I think it's got 4 sections in it. 5, 6, 7. It's free. Now, if you say, oh, I don't have time to do it, then don't do it. I would recommend that even if you say you don't have time, I would go over lesson 4. Notice it's called debugging. Great workflows for debugging problems in your JavaScript. But it explains the other things that are available under Chrome's developer tools. There might be something in there that over time might be able to help you. So I would suggest going through the first lesson, period. And if you think, that's not too bad, then I would, if you say, I don't really have time to go through these next lessons, then I jump right to lesson 4. All right? Again, if you don't want to do that, you're not going to do it. I understand that. All right? But I have a lot less sympathy for you when you're debugging if you've never tried to use any of these other resources. Your book will only show you so much. I can only show you so much. All right? There's another thing in here. You can bring this up, but you don't have to. I'll show you what that one is too. Another URL that's right here. developer.chrome.com/devtools. That's kind of the home page for the developer tools. And I'll give you a second, so if you want to type that in, you can. You're getting all these URLs, just so you know that. Okay? One of the things I sent to you today was a bunch of URLs. But if you look right here, notice how it says Chrome DevTools Overview. And notice along the side, there's a thing over here that says Debugging JavaScript. So if I click there, it's not very big. This is the whole section. All right? But one thing that's nice about this is notice at the top of the document, the very top, it says, for the latest tutorials, documents, and updates, go over to here. You don't have to do that, but if you want to, you can. Also, notice that when I go down to the JavaScript and I go down to the bottom, read more about how to debug JavaScript with the DevTools. So I'm going to click there, and it's going to show me a little bit more, it's going to show me this in a little bit more depth and breadth of coverage. All right, I've got other things for you to look at also. All right, but again, I can appreciate it when somebody says, you give us so flippin' much stuff in here, I don't have time to look at 10% of it. Well, then make sure the 10% you look at is worth your while. All right. All right. So they start talking about tracing on 241, and then on 242 they show you how to bring it up in different, different browsers. What I've shown you is hitting the F12 key. That works. And hitting it again, but they mentioned you can do a Control plus Shift plus J, and there's a bunch of other ways you can do it. If I want to right mouse, if you look up on the screen here, I can click here under the Customize. And where is it? It's someplace in here. More tools, I think. Developer tools. That brings it up. All right. And typically, if you're on a document someplace, if you're on a document and you right mouse click on the document and you go to inspect, that'll bring it up. Look at the difference though. When I brought it up with inspect, now, for example, if I click in here, let's say right there, I'm going to click right here. Now it shows you all of the all of the CSS that was set up for this. Now, is that going to help? It might help you when you're creating your site. When if you remember, we don't have that much time left in this class. I think after today we've got like 6 weeks or something like that. All right? And on that last day, you are expected that you're going to have that portfolio updated. And you're going to add some of your links to JavaScript, etc. in there. One of the things that you're going to be graded on is how professional it looks. It is a professional portfolio. It's the kind of thing that you could give a potential employer. And I'm going to grade it as though I'm your potential employer. All right? So you do an exercise with this stuff then on 244 and on the top part of 245. Now, turning up to 245, they talk about setting breakpoints. Question for you. Have you ever seen this? Because I've done it, where I accidentally click and I get this. Oh, why is it showing it to me? Oh, I haven't saved the file yet. I'm going to just save this file for right now. Just throw it onto my desktop, and I'm just going to call it junk.js. All right, I don't want to keep it anyway. But I'll make that a comment, because I don't want to get an error there. And I'll make these comments, and I'll make these comments, etc. And I'm going to click over here. Why? Why is it whenever I want to show you something, nothing works? Well, what I was getting to was, do you ever see that where you get the little blue dot over there? That's setting a break point. So what I can do, and let me try to see if I can show it to you this way. All right, if I go over to the console here, all right, and I start typing some stuff in. In fact, let's bring in. This isn't what you asked, Evan, but I'm kind of doing it in reverse, where I think I can come in here and bring that in. See that? So I can do that if I want to. All right. So I can come in here and I can try doing different things. But what I am able to do, and again, I don't know why it's not letting me do it, but I can come in here and set what are called breakpoints. When you set a breakpoint when you're debugging, the program stops execution on that line. Did you hear that? It's really important. All right. So if I wanted to set, maybe I wanted to add another line here or whatever, I can create a breakpoint anywhere in there. And I think it's because of where I am on here. I don't remember exactly where I have to be to set this. If it's here or not. Well, let's look at how they do it in the book, because they'll show you the right way of doing it. All right. So the author has you go through an exercise starting on page 245, and it goes 245, 246, 247, 248, 249, and 250. Then he shows you how to clear it on the bottom of 250. Please take some time to go over that, all right, that exercise. Now, to show you what I mean, though, and I'll show you it on here, all right, what I could do, and again, it is never not let me set a breakpoint like this before. But if I click here, I'll get a blue dot, and then when the program runs and it stops here, typically you could take your mouse and I can hover it over the N1 and over the N3. It'll show me the values of those variables. All right? So let's say that before this, let's say that I had said this. var ANS for answer equals N1 plus N2. All right? Now I put a breakpoint right here on line 18. You all see that? So I put one right here. Right there. Let me create one that way. No. So I put a breakpoint there. Well, then it'll stop before it returns this, but I can take my mouse and I can put it right over where it says ANS, and now I can tell whether or not ANS holds the right answer. That's how you use breakpoints. And when you do that, you typically click over here to set one, then you click again right on the same spot you set it, and that clears it out. Okay? Now another thing that you can do, and I'm turning all the way up to page 251 in your book. On page 251 in the book, they talk about stepping through your scripts. And there's different ways that you can step. You can step into, which means you want to go into a function. You can step out of, where it means you step out of a function. You can literally run your program where you use something that's called step through, where you keep hitting one of the function keys and it executes your code a line at a time. Can you see an advantage to doing that? Especially when your code's not working? So if you make sure you spend a lot of time on these exercises where you step through this stuff. All right? So let's say you're doing that and you're still confused. You're like, Jeff, I did everything you told us to do, and I don't know if it's me, I don't know what the heck it is, but I'm still having problems. All right? Then, if you turn up to page 253, and here the author shows it. So notice those are the buttons that you'll use. So if you're using IE, those are the ones you'll use. If you're using Firefox, those are the ones you use. If you use Chrome, that's what you're going to use. The buttons that are over here. And he explains what they do. Take your time to go over that exercise. So again, you've done all that, you're still having problems. And for the life of you, you can't figure out what the problem is. Then what you can do is you can put on what's called a watch on your variable. Any variable that you declare at the top of the program with a var, remember how that's a global variable? You can put what's called a watch on that variable, and then part of your debugging window, as the program runs, it'll keep showing you the value of that variable as it changes. You see where that might be valuable. What's kind of cool, you can even go in there while the program's running and change the value yourself. All right? You're not permanently changing it, but if you wanted to see what would happen if you did something, you can do that. So there's an exercise on 253, 254, 255, 256, 257, 258, and the top half of 259. All right? I'd strongly suggest you spend a lot of time going through those exercises. All right. Then turning up to page 259, the second part of the page. I'm going to show you something, and it may or may not make sense. If it doesn't, it's no big thing, but I just want to show it to you. All right, so I've got this, and I've got that. I'm going to get rid of all that stuff and make this look nice. All right, so I'm calling add to, and then I'm going to say var a equals sub 2, number 1, number 2. Var b equals times 2, number 1, number 2, and var c equals div 2, number 1, number 2. So I'm going to take this whole thing we've got right here, sub 2, and we'll fix this, make that a 2 and a plus. And we said we were going to have a times 2. And we're going to have a div 2. I'm not going to worry about dividing by 0, etc. Does it make sense? I'm asking you this. Does this make sense to everybody in here? That what I'm doing is I'm going to have 10. Here, this will be 10 plus 20, 10 minus 20, 10 times 20, and 10 divided by 20. Does that make sense to everyone? All right. I'm going to explain this, and then we're going to take a break. Every time I call a function, control of the program goes from this line right here to this line right here. Does that make sense to you? But what the computer has to do is it has to say, okay, everything I've done up till this point, it takes all that and it throws it up into a certain area of memory that's called the stack. It's a temporary area of memory, just in case this gets screwed up and it has to come back over here again. So it does that. Everything's cool. So then it calls this one. And guess what? It does it all over again. And then it calls this one. Then it calls this one, and it does it. So what it's doing is, okay, so I'm in main, control goes over here, I do this, I do this, I do this, I do this, I come back here, etc. Do you understand what I'm saying? That's how it steps through the program. All right? This won't be that big a thing in here, but next, well, really, I guess a year from now, or a year from spring, in the Java class, your programs are going to start breaking right away. All right? And there's a real good reason for it. Java doesn't allow you to check things as easily as most other languages do. But what the program will do when your program breaks is it'll give you what's called a stack trace. So it'll show you what routine called what routine, called what routine, called what routine, and then either on the top or on the bottom, it'll show you where the program broke. Okay? That's what they're talking about in here when they're saying examining the call stack. That starts on the bottom of page 259 in the book. Why should you know that? Well, for no other reason, it's on the test, as I believe, as far as one of the questions that's on there is what is the call stack. An ordered list maintained by the JavaScript processor containing all the procedures that have been called but have not yet finished processing. It's, for lack of better words, it's a history of your program. this call this, etc. Sometimes, as a last resort, you just for the life of you cannot figure out why your program isn't working. So you can do a stack trace. They show you how to do that in the exercise on 260, 261, and 262. All right, that was long. I don't normally go all the way till 9. But let's take a break. We'll come back at 9:10. Believe it or not, we only have about 10 or 15 pages left of the chapter. But I'm going to pick it up on page 263 on handling exceptions and errors. All right?